Hi everybody. We are going to continue on the last topic, but not least, the type of failure due to reinforced concrete. Okay, as the applied moment on the beam section is increased beyond the linear elastic phase, the concrete strains and stresses enter the nonlinear phase. The behavior of these beam in the nonlinear phase when the maximum compressive strain exceeds EC2, as I shown you before, depends on the amount of reinforcing steel provided. Alright, depending on the amount of reinforcing steel provided, flexure failure may occur in three ways. Okay, the first types of failure is a balanced reinforced beam is one in which both the compressive and tensile zone reach yielding at the same imposed load on the beam, and the concrete will crush and the tensile steel will yield at the same time. This design criteria is actually, however, as risky as over-reinforced concrete because failure is sudden as the concrete crush at the same time of the tensile steel yields, which give a very little warning of distress in tension failure. So, the concrete crush and steel yield simultaneously at the ultimate limit states. The compressive strain of concrete reach the ultimate strain, while the tensile strain of steel reach the yield strain simultaneously. The depth, as you can see in figure here, the mode failure for balance, okay, the depth of the neutral axis is equal to 0.617 D. Okay, this is for balance. Okay, failure mode of balance section. Okay, the next flexural failure is due to under reinforced. Alright, so under reinforced beam is one which the tension capacity of the tensile reinforcement is smaller than the combined compression capacity of the concrete and the compression steel. Okay, when the reinforced concrete element is subject to increasing bending moment, the tension still yield while the concrete does not reach its ultimate failure condition, as the tension still yields and stretches, and under reinforced concrete also yield in a ductile manner, exhibiting a large deformation and warning before its ultimate failure. In this case, the yield stress of the steel govern the design. So, picture here show failure mode of under reinforced section. Okay, so compared to the balanced failure, okay, this under reinforced experience the depth of neutral axis less than 0.617 D. Okay, the onset failure is gradually, okay, which giving ample prior warning of the impending collapse. Okay. Alright, we move to the third failure, okay, which called over-reinforced. An over-reinforced beam is one in which the tension capacity of the tension steel is greater than the combined compression capacity of concrete and steel. Okay, so the over-reinforced concrete beam fails by crushing of the compressive zone concrete and before the tension zone steel yields, which does not provide any warning before failure as the failure is instantaneous. Alright, this figure shows the failure modes of over-reinforced section compared to the previous failure. Okay, the depth of natural axis is greater than 0.617 D. Okay, the failure is sudden without any sign of warning and brittle. Okay, for this reason, over reinforced flexural members are not permitted. Okay, so may I ask you, steel reinforced concrete moment carrying element should normally be designed to be under reinforced, over reinforced, or in a balance reinforced? Can you try to answer me? Which one? From these three failure, which is we have to refer, should normally be designed? Okay, it's okay. Let me share you the answer. Alright, so steel reinforced concrete moment carrying elements should normally be designed to be under reinforcement. Okay, so it's under reinforcement so that the user of the structure will receive warning of impending collapse. Alright, why over reinforcement can't be used in our design? Because if a large amount of reinforcement is present, then the concrete will fail first in the brittle. Alright, so I hope this video can help you on understanding the failure of mode for concrete reinforcement. Okay, again, we should know the balance under reinforcement and over reinforcement failure in beams. Okay, thank you from me and thanks again for watching. See you next time.